Namaskar, good evening, salam alaikum, and welcome to the 51st Outreach and Knowledge Transfer OKT webinar on very important topic today, understanding reactive hazards of chemicals, process safety management, a must know for HSE professionals. Today is 22nd July 2026, Wednesday, 20:30 hours IST, 18 hours AST, and 11 hours EST. We all welcome you for this particular webinar. Very important and basic understanding reactive hazards of chemicals for every HSC professionals. So I would like to start the program with the meeting protocol. Kindly mute your microphone and raise the hand whenever you want to speak. Of course, the connection is very important. You can switch off your camera and switch on when you want to speak. Post your queries, comments, suggestions in the chat box. This meeting is being recorded for our future reference. Kindly register your name, company designation, phone, email ID in the chat box. And again, most important thing, please stay for a ceremony group photo at the end of the vote of thanks. And again, please invite your friends for joining. Again, it is going to be a very important webinar. Certificate of attendance will be provided for full session attendees only. Full session means full session. And on the right side, you see the QR code there. This QR code takes you to the wealth of knowledge, 24 hours WhatsApp knowledge hub of the J&A Bharat HSE Foundation and J&A Global HSE Foundation. With that, I just want to brief you that today it is going to be two-part agenda. And after introductions, we have the release of ebooks. Very important announcement we are going to make today. After that, there will be a part two of the important technical session on the understanding reactive hazards of chemicals, process safety management, a must know for HSC professionals. Then we'll have a Q&A session. Then very important launching we are doing today, launch of J&A BHF AP SHAF, which is Students HSC Fraternity of Andhra Pradesh State, India. And then we'll have a networking and open discussion. With that, I would like to start with the agenda part one with the quick opening remarks from our beloved founding trustee, Mr. Jitu.
Thank you, Ashokji. Good day and namaskar to all. Honored guest, our today's respected guest speaker, Dr. Hari Bhukia, who is the Senior General Manager of EHS and PSM Hitro Group, Hyderabad, India. I want to mention the name Professor Ramana Guru, Dr. Lakshmi Narayan Guru, Ram Prasad Guru, who is the Director of Bharat Ray, Mr. Jivannath, Adjunct Professor at IIT Madras, and most importantly, all the dynamic HSE students who just mentioned the name from Visakhapatnam and elsewhere, who are our future of the nation, and also HSE and other professional leaders and distinguished delegates. On behalf of J&A Bharat and J&A Global HSE Foundations, a very warm welcome to you all to the Foundation's 51st and the most significant outreach knowledge transfer session by Dr. Hari Bhukia. Everyone knows my good friend and co-founding trustee, Mr. Ashok Garlapati. You just met him in opening of the session, who has made remarkable contributions to the HSE profession and also has developed countless number of HSE professionals globally. Ashok ji has been recognized by the Board of Certified Safety Professionals. He served that organizations of the world's famous and the most reputable organization as a president of the BCSP, director, and so many other crowns he has won for BCSP. But above all, he was also bestowed upon the most prestigious and the highest fellow honor award offered by the oldest and the largest health and safety professional organization, American Society of Safety Professionals. He is also the fellow of IOS. Ashok ji, please do us the honor of conducting the proceedings of today's webinar. The floor is yours. Thank you.
Thank you, Jitu Saab. Thank you very much. And Mr. Jitu is a fellow of ASSP, and he was first introduced ASSP International Chapter outside US in 1983. Still that growing and giving the fruits today as well. So thank you very much, Jitu Saab. And we both have started this foundation. And we just want to give a little background about this foundation because, as Mr. Jitu said, there are a lot of future leaders attending today. I mean, students. So we just want to give them a background of our foundations today before we hand over to our speaker today. So all the blue flags you see on the screen, these are the places which are the countries where myself and Mr. Jitu have really supported HSC fraternity. And we wanted to do something more to India because in India there are so many organizations are already available, but the concept of the foundation is something new. We have a ASSP foundation, we have a BCSP foundation, we have IOSH and other places, but nothing like in India. So we brought this particular foundation concept to India. As you see on the screen, there is a ILO, International Labour Organization statistics. Unfortunately, India is on the higher side. And remember, these are only the reported incidents. There are so many unreported incidents are happening, but our main aim is to support the industry, support the HSC professionals, and support the HSC fraternity. With that in aim, we started our foundation. It is virtually on the 25th March 2022. Again, during COVID time, everything was virtual. So we adapted virtual so significantly for the benefit of our HSC profession. That was Bharat HSC Foundation. Further, based on the request from the different parts of the world, we started a global HSC Foundation on 30th November 2022. That's on the 30th November 2022. Again, this particular foundation is not at all a membership organization. You don't need to pay anything to get the benefit from this. We are only giving back to the profession in association with the professional organizations, corporate organizations, academic institutions, like individuals like Dr. Hari joining today, and the philanthropists and NGOs and other things. So it's purely a giving back organization. No need to pay anything to join our fraternity at all. And we have a mission, vision, also objectives. Our mission and vision is very, very simple: to support HSC profession as well as the HSC professionals, basically to do the advocacy for our profession. And our objectives are: we are advancing occupational safety and health profession among the industry, academic institutions, and organizations, to support and promote occupational safety and health as a career choice among students, to inspire and develop leaders, to provide education and development opportunities. We also recognize individuals. We conduct subsidized HSC training programs, awareness sessions, and also we have a MOUs with the organizations having the similar objectives. And we have a wonderful editorial board, again on completely voluntary basis. Mr. Madhu Nalan Chakravarti, who is based in Hyderabad, India, is very, very passionate about our HSC profession. He is our chief editor. Dr. Lakshminarayan Prodhutur and Mr. Venkatramana Ponla is our editorial board. We bring up newsletters on every month with the different topics, ongoing topics, bringing the advanced technologies. And we have an excellent editorial board making the articles contribution with the support of the fraternity. On the right side, you see the different activities we have in our foundation. Again, today we have a full agenda. We don't want you to go through every activity. And recently we launched a learning management system, again fully on complementary basis. Our good friend, Mr. Sheikh Maqbool, is from Anantapur, Hyderabad. And he is basically, let me just on screen. Yeah, he's basically HSC professional based in Kuwait and is a tech savvy. He is supporting and launching our learning management system as well as social media channels. We launched this learning management system 2 months back. Everything is free. Since students are there, I'm just telling you again, you can go to this website and find out the courses of which you are interested. So just to go and find out and explore. And another important thing is today we are launching the 4 ebooks for J&A BHF and J&A Global HSE Fraternity. Again, these are authored by Mr. Madhu Nalan Chakravarti. One book, I was also part of that, but we really truly appreciating his efforts. Today, we are launching these 4 ebooks. And before I announce, these 4 ebooks are available in our website. I'm going to share the link as well as a QR code so that you can go there and explore these 4 ebooks. And Mr. Madhu Nalan Chakravarti is traveling from Vijayawada to Hyderabad by road. He sent a special message to me. Before I read out that special message, I just want to show you the QR code. You can explain. These are the books we are launching today. All ebooks, very, very good information. Number one is process safety modernization and digital transformation in steel plants. Second book is 5D framework, building competence in the age of data and AI for the OSH professionals, mainly for the occupational safety and health professionals. Last week, I was participating in an IOSH UK webinar, mainly on the artificial intelligence, how to cope up with the requirements, competency. So I presented this book there. We got a very good feedback. Mr. Jitu shared yesterday the recorded session of that particular panel discussion. You can go and check in our WhatsApp group also. You'll find that. Again, I'm telling you about this 5D framework. It talks about the data, digital, and decisions, determination, and duty, and what occupational safety and health professionals have to do to cope up with the AI and data, how best we can make use of these tools. That is what is mentioned in the 5D framework. It is by myself as well as Mr. Madan Nalan Chakravarti. The third book is the process safety in an integrated steel plant. That's also related to the today's topic. And the fourth book is a smart transformer monitoring and solutions. Before I go to the next slide, I just want to say, give an opportunity to Mr. Jitu on behalf of Mr. Madhu Nalan Chakravarti to talk about these books. Mr. Jitu. Okay, it looks like Mr. Jitu is on the mute. And let me tell you about these ebooks. Mr. Madhu Nalan Chakravarti has sent his little background about this book. Basically, process safety modernization and digital transformation, steel plants part 1 and 2, a comprehensive guide that brings together the principles of PSM and the transformative potential of Industry 4 technologies. This book explores how integrated steel plants can strengthen safety, reliability, and operational excellence by adopting global best practices alongside emerging digital technologies such as AI, Internet of Things, digital twins, predictive maintenance, industrial cybersecurity, and digital substations, covering topics from hazard identification, risk assessment to emergency preparedness, functional safety, asset integrity, all those things. More than a technical publication, this ebook is a roadmap for building safer, smarter, more resilient, and sustainable steel manufacturing organizations. It is our sincere hope that it will inspire professionals to embrace innovation while keeping process safety at the heart of every operational decision. So this is our editorial, editorial board chief editor, Mr. Madhu Nalan Chakravarti's input for this release on the occasion of the release of these ebooks. So with that, you can take the screenshot of this as well as you can go to our website to get these ebooks on on complimentary basis, again on the giving back basis. With that, I would like to go to the second part of the agenda. We are just late by 1 minute or so. We will be going ahead with the understanding reactive hazards of chemicals, process safety management, a must know for HSE professionals. Jitu Saab, are you ready to speak, or shall I hand over to the
I think you covered it all. Only thing I was going to add is that this is an excellent tool for developmental programs for all the students as well as the full-fledged HSE professionals. They can further exceed their knowledge out of these books and use them as the reference books. Thank you, Ashokji. Go ahead.
Thank you so much. I see one Mr. Sivaprasad raised the hand. If it is related to these ebooks, you can speak, sir. Otherwise, we have to go ahead with the agenda points.
Good morning, sir. Thank you very much. I am also
Yeah.
interested to have these books because
Okay.
the link is given here very nice. The session is very good. Starting it in itself is telling the about the session. So I would like to have the link to my email because I am not able to
Sure,
get
sir.
it here to note down. Thank you.
Certainly. You can take the screenshot, then you can do the QR code, and we will also share the link in our WhatsApp channel as well. Okay. And we are
Thank you,
going
sir.
to share. Yeah. We are
Shivaprasad, you
going
will
to.
get it. You will get it. Okay.
Yeah. Thank you, sir. Thank you, Jayanti garu.
See at the end. Questions at the end,
Okay.
please. Answers.
Yeah. Thank you so much for that comment. And we are going ahead with the part 2 of the agenda. Our Mr. Jayanti Lachaya Garu is our J&A BHF advocate for AP Chef. Chef, we are going to inaugurate after the session. Mr. Jayanti is a committed professional with experience in technical and safety-related fields, particularly focusing on electrical safety and safety management institutions and environmental. People who are part of our WhatsApp group knows how much value addition he is giving to this fraternity. Today we are inaugurating the AP Chef and another baby we are giving to him. Let's see how he nurture that. But before that, I want to request Mr. Jayanti to introduce our today's speaker. Mr. Jayanti Garu.
Good evening, everybody. Ashok Garlapati, Jitubai, and everyone. Today's speaker is Dr. Hari Bukia. He is the Senior General Manager, EHS and Process Safety Management, Hetero Group, which is having 36 industries in India, and he is the Corporate Group Manager for all the 36 industries. And apart from that, his academic qualification is BTech and MTech, and recently he was honored with a honorary doctorate. And his professional profile is 18 years of industrial experience in EHS and process safety management, and is expert in OSHA, that is WASHA, PSM, and CCPS risk-based process safety, and is leading high-performing team member for safer sustainable operation, is the lead. Apart from that, is passionate about engineering excellence, people safety, and operational reliability, and is an eminent speaker and a trainer. And his areas of expertise is not limited to the following, which I am reading now, and process hazard analysis and risk assessment, chemical reaction hazard assessment, and thermal stability studies, and reaction calorimetry and process safety testing, dust explosion and powder safety studies, safe scale up approach and technology transfer, design safety engineering, plant automation, interlocks and layer of production, EHS management system, ISO 45001, and compliance excellence. And this is very few things which I wanted to tell you, because I keep on, if I keep reading, it will take full time. So I request Ashok Garlapati as well as Haribukia and Jitu Bhai to excuse me. And with this,
Yes.
I welcome Mr. Haribukia and I hand over to Ashok Garlapati ji and Jitu ji. Thank you.
Thank you, Jayanti Garu. As you said, I was going through his profile. It's a very, very excellent value, rich value in process safety issues. So, thank you, Jayanti Garu, for introducing Dr. Hari Bukia. Let's continue with our Dr. Hari Bukia. Handing over the floor to you, sir. Virtual floor to you.
Thank you very much, sir. It's an opportunity for me. Especially thank Ashok ji, Garlapati Garu. I'm so thankful to you for making me this presentation in this forum. And Jitu Patel ji, as a founder member of J&A Bharat. I'm so happy that I seen him. There's a lot of experienced experts in this forum particularly. And another person who is a special person, that is Lachaya Garu, Jayanti Lachaya Garu, who's introduced me to J&A Bharat. So thank you very much, sir, for this. And thank you. And coming to the part of subject, sir, I'm going to share the screen. I'm getting ready,
Yes,
sir.
please.
Yeah.
Go ahead.
I'm sharing the screen right now. So hope you all people are seeing the screen.
Yes. You can put on. Yeah, perfect. It is perfect. Yes.
So thank you. Very good evening and good afternoon. So thank you very much for this. So today's topic is understanding chemical reaction hazards and process safety management. So this brief, we are going to have a small introduction. Already, I think Jayanti sir and all people are introduced to me. This is my profile, and these are my certifications where I did like a state board of few certifications whenever I get a free time. So I used to do some certification programs. So I have not added few things, but still I covered NIBOSH, sub THT, HCl, Metlus, DNV, TUV, Ecutex, or maybe government bodies regulatory courses. And as well as I worked for Pfizer, Arigen, Alembic, Dr. Reddy's, Mylan, and Asian Paints corporate managers. So this is my profile where coming to the part of the real, where I worked in Hetero, my few legends who are there standing in the screen, I think you are seeing the screen, the two legends, the chairman and the managing director of Hetero Group, they used to say that make every shop floor employee should be aware about hazards associated with his activity and surroundings to avoid human errors and incident during the process. The wonderful thought, whenever I used to meet the chairman and he used to say that, Hari, if you are doing good means I need to see the person who is standing in front of a reactor or he is doing any activity. He should know minimum hazard which is who's doing it. So he should be aware about hazard associated with his activity and surroundings. So then we can avoid the incidents, accidents, and zero incidents. So this is the few words of our chairman on the safety. Thank you, sir. Coming to today's topic, particularly today's basic challenges, we are going to have a discussions on today's basic challenges for any industries, not only the pharma, chemical, steel, any industry, name the industry, the challenges, whatever we are facing, we are going to have a discussion. And global process safety incidents and contributing factors for the incidents, factories amendments, which are happening in India, particularly the recently one state has changed some amendment about the process safety and comparative approach of process safety management in the worldwide organizations and compared to comprehensive of particular risk assessments, methodologies and tools and basic standard approach of process safety management. We have a lot of standards in the world in process safety challenges. It may be a chemical industry, pharmaceutical industry. What are the in process challenges? Typical unit process and operations. Process safety package. What is this package? This is a new package which is developed based on our expertise, which we are doing in pharma and chemical industries. And how to know my process is safe or not. See, standing in front of a reactor or any of the chemical reaction, if you want to know that this process is safe or this reaction is safe or not, before leaving this class, I think this session, I'm damn sure that definitely you will know that if you just put in these points, definitely you will understand, oh, this process is safe or not. You can understand that's the way simplified after doing thousands of reactions in the reaction calorimetry in process safety laboratory. So that we are going to have a discussion this and understanding powder safety and understanding of dust explosion severities. So that we are going to cover in this topic. So I think so I'm open to you. So within a 60 to 90 minutes, we may not deep learn, but at least I'm damn sure you will learn something, and I will make you ensure that before standing up, or it is a non-chemical also, you will see that, oh, chemical industries, how this is working also, we can have understanding in this presentation. Coming to the total, today's basic challenges. Yes, today's basic challenges for any industries. So I think that if generally it is in a one-to-one any sessions, we used to have a question and answer in this case. So today's basic challenges, yes, agree. Challenge one, decrease production cost. Agree? Yes, agree. So every company, manufacturing company, it may be a chemical, pharma, textile, or maybe any company, steel company, they want to decrease the production cost number without compromising the quality. That's the condition one. Country challenge two, to meet the regulatory and statutory compliance with evolving environmental safety, labor, quality regulations. Again, we need to meet it. Any factories. And challenge three, attrition rate. So today I joined. I think one skilled labor has joined. Within a 6 months or 1 year, he left. So maybe whatever the stress happens, whatever the involvement happened between the management and the people as well go off. So the main intention is today he joins, tomorrow he learns, day after tomorrow he leave. Maybe every time there is a fresh talent will come into picture, but again we need to train it. The productivity also impact on this shortage of training personnel particularly. Challenge four, Safety issues with complex operations, maintaining zero incident is tough. So I really observe. So this is one of the, I think, 4 challenges, which is a few challenges only I'm putting with respect to any industries out there, right? So in these 4 challenges, I really appreciate industries who are manufacturing without compromising, they are reducing the production cost without, they are meeting statutory, they are meeting the attrition rates also, they're making safest one, they're making safe complex one. This all meeting and they are giving us a salary. So I really appreciate. I think if you are, I think we need give a good round of applause to them. Seriously, they are meeting the standards, or government are pressurized. Any instant happened, their branding levels are down. So this is the way of, I think, we are facing the challenges for any industries on this. Now, coming to the part of global process safety incidents in the pharmaceutical industry, contributing factors for major incidents. If you see this in the Journal of Loss Prevention in the Process Industries elsewhere, it is telling that in global process safety incidents in pharmaceutical industry, number of incidents and corresponding percentage with respect to the other countries. Like if you see in the graph, the pie graph, the blue US, India, China, other and unknown. So that means in India, there are number of instances and corresponding percent to the all other. We have 28 to 38 percentage of, I mean, compared to all over the world, we having the number of instances are very high. The similar way, in the same journal, it is mentioning that number of fatals, see, which I told in the last slide is number of incidents. In this case, number of fatals corresponding percentage which I'm mentioning again, which is fatals. That means people are dying. So in these fatals, India is playing a major, bigger role in the fatalities which is happening. With respect to previous slide is an incident, it's an fatalities. This slide which is telling you that with respect to which type of category it is, maybe explosion, fire, gas, or chemical release. So again, there is an explosion. So nowadays, anywhere you see that there was an incident happening means in world, India is playing a major role in incidents. Fatalities, India is playing a major role in this. And this one again, type of incident explosions are happening in India. If you see this in Hyderabad as well, Telangana, Andhra Pradesh, in other maybe Maharashtra, Gujarat, wherever the states, any incident happened, there was a reactor explosions. So this is the way which I just articulate, which we collected from the elsewhere journal in this case. Same if you see that, so number of incidents and contributing factors which are mentioned in the graphical way. In this, what is the reason behind? So only thing is getting the answer is hazard awareness and identification. So if you have hazard and awareness identification, will you have it? Definitely there will be no incidents. At least we can control the incidents. So whatever we are doing right now, so we are doing whatever hazard awareness I'm doing it, and you are going to do identification, simple way. So J&A Bharat also, it's very clear in J&A Global also giving a global opportunity to the people are giving awareness about the whatever the hazards we have in the safety, and they are giving the best way that way. So hazard awareness and identification program can decrease the global incident rates, fatal rates, and accident rates. So it is the latest update in 2025 May, 2025 13th May. Maharashtra government has done some amendments in this. For every chemical reaction, if you do it, the occupier shall be carried out any exothermic chemical reaction for the first time in the reactor or anything. They have to do minimum basic process safety assessments. So I'm going to, before going to the subjects, few slides are there. So after few slides, we are going to direct to the subject. So this is the basics ones to make you understand why process safety is important. So in this, see, I think if you see this, they have to carry it out, they need to do the coupon test, heat of reaction from the reaction calorimetry, heat of decomposition of your chemical, where it decomposes, where it runaway reaction happens, what is the maximum adiabatic temperature of your rice, what is evaluate the cooling capacity. See, you know your reaction is giving some exothermic. So your reaction is giving some exothermic. So how to evaluate it? So how much of cooling capacity is required for this cooling these reactions. So runaway reaction using criticality of classes and safety margins, inadequate rates or order of reactants and agitator capacities, circulation pumps, as well as in this, I think we are going to have a discussion. All the whatever underlined before leaving this session, you are going to understand very easily. It's a dry subject, but seriously, before leaving this session, you'll understand what is this what is happening with chemical reactions, what is the chemical reaction hazards we have in this, so how to predict it. So in front of standing of reactor or reaction, how to predict this, my reaction is safe or not. So what are there? We are going to have a discussion on this. Again, coming to the topic of this comparative analysis. See, many people used to tell that you used to do HAZOP, please do HAZOP, please do ABR, activity-based risk assessment. You do HAZID, has gone. So whatever the maybe the standard, I think we do it. But coming to the part of, before going to this, a comparative analysis of process safety management system in the process industries. In world, there are 20 standards. If you see in the maybe in the first row, 20 standards in the first column, 26 elements. So which is the best one? Which is, so it is mentioning like OSHA, CCPS, DuPont's, ILO models are more robust, are more flexible in the pharma and chemical industries, which I mentioned in this. If you see this graphical way, if you see the graphical way, more one, which is mentioning in this, which is having more robust, which is having more flexible with respect to implementation of the process safety management in the plant. With respect to chemical, if you see this chemical or maybe pharmaceutical or maybe in maybe any industry with respect to petrochemicals or oil and gas industries, so we can select based upon this table which is mentioning in this. So this model, PSM model, works for oil and gas. This EPA and RPM model works for chemical and petrochemicals. This OSHA's, DuPont, CCPS works for the chemical and pharmaceutical industry. So these are the mappings which is done with respect to 20 standards in the world, and which is having 26 elements, which is mapped on the screen. So this gives a glimpse. Oh, I need to choose. My industry is this. I'm from a steel plant. I'm from a textile industry. I'm from a pharmaceutical. So we can choose it, and the best and robust one, which is mentioning with respect to the manufacturing sector. So it is giving like, I mean, if you're seeing this DuPont and Energy Institute PSM and CCPS OSHAs, which are having a more flexible and more robustness. So this is about the and a glimpse which is having the standards in the world. So if you see this mandatory in India, it is not mandatory to follow the process safety management. We have a Factories Act 1948 as per the sections, which is having different sections that we used to follow in India, but particularly in other countries, they have some mandatory in US as well. And coming to the part of risk assessment, in the early stage, I told you about the many people used to talk about the risk assessment. Sir, I want this, I want HAZOP, I want HAZID, I want JSA, I want ABRA, I want what if, FMEA, LOPA, bow tie. So I think there are a lot of few things, I think not able to fit in the screen. That's the reason I have written only few things. If you see this, everything has a specialized when to be used. Simple way. When to be used. HAZOP, I need to use in design and modification phase. Or HAZID, I need to do in early project stage. Or JSA, before task using. So any non-routine, this is having a significant one, JSA. So any non-routine activity or routine activity, you can capture it. The job safety analysis, you can do it. Any routine activity, you can do it in ABRA, or what if analysis for your process or anything which you manufacture. So every tool which is mentioning in this has a significant role when to be used. But the basic fundamental of any tool which is there, it is a risk assessment definition like identification, evaluation, and control. Simple way, as we are learning in this session. So any tool, if anybody tell you want to do it something, you want to design, you want to project, you want a high risk activity, you need to be deciding that is still activity or maybe hazard communications, anyone which we do it, the simple way we do it, we need to understand what is risk assessment. Oh, I need to identify, I need to evaluate, I need to control. So this we put it in the different formats. This is the comprehensive of the risk assessment methodology tool which is mentioned on this. Which is going to the next one, which is a basic approach of process safety management standard. See, every company has a different types of understanding. See, in chemical and pharmaceutical industries, see, company to company, the process safety management standards, which I mentioned in the previous slides, like, there are 20 global standards we have. In that, there are 26 elements we are mapping it, right? So OSHA, CCPS, DuPont, maybe Energy Institute. So based upon that, but simple way, which I implemented in the hetero. And when I was in Pfizer also, I worked for Pfizer, I worked for Dr. Reddy's as well, different pharmaceutical and Asian Paint as well. So when we approach a basic approach, when you're starting from a scratch, you start with this. this is the way which I am drafted this one. So this which you screen on screen, this documentation gives a basic process safety management implementation in your chemical or a pharmaceutical industry. And this. So if you see this, I started immediately when I joined an Hydro, there was no process safety management department or a process safety person in this. So immediately we started. I catched with the quality people where you start a change, there I need a change control. So for every change with respect to man, machine, material, method, environment, equipment, utilities, documents, software, supplier, safety regulations, or anything, you need a change control will be initiated and authorized by the EHS and process safety respected department. This was we taken a challenge immediately by taking this. If they want to change in a man, machine, method, like all M's, all with respect to the any physical or any scenarios, situations as well. Immediately, based upon that, we give a recommendation if it is a process, if it is an activity, if it is in a procedure, if it is an equipment changes. So simple way, based upon the change control approval, immediately I started giving, oh, I need a process safety information, maybe this kind of data, which I'm putting into thermal stability, reaction calorimetry data, or powder safety data, gas evolutions data, stoichiometric balance, compatibility charts, nitrogen blanketing, emergency vent sizings, maybe condenser vents, OEB, occupational exposure limits, bandings, and P&IDs, PFDs, interlock. So I'm just putting a word where whichever based upon the change happens, I choose this which is fitting for this particularly that activity change that I'll put it in this. So you need to do the HAZOP or HAZID, which I told I mentioned in this, the previous slide, which is mentioned that I'll choose. If we want to do activity-based risk assessment, they want to do HAZOP, they need to do job safety analysis, what if analysis, they do it. But we selected, will tell that for this activity, we'll put it in this activity. So that will they comply. So process safety information followed by process hazard analysis. And whatever we developed in the process safety information and process hazard analysis, it was kept into the operating procedures. So now coming to the point of operator. So operator should know he may not be a chemical engineer. He may not be a chemist who is standing in front of a reactor. He's manufacturing a pharma or medicine in the plant. He don't know what is a chemistry, so he need to understand it. So based upon this, so in batch process records, we call it, different people call as a batch manufacturing records or batch process records. So then we'll start it. BPR safety instruction will put it. So like this, if you charge this chemical into the reactor, so you need to take some precautions, with respect to PPEs, or with respect, if you charge it, there will be exotherm, there will be a gas liberation. So all the data we gather from the process safety information, all the hazards we identified from the process hazard analysis, we put it in this operating procedures to make the operator understand and get trained on this. And then when the process starts, we do process pre-SSR, like pre-startup safety review, with respect to process, with respect to equipment. So this is the basic one. When you involve this is for, immediately this captures the employee participation. Who is there? The employee is involving in FEHA, the employee is involving in the operating process. So all the way, this employee participation will be captured. That kind of involvement in PHA, instant investigation, mock drills, safety committee meetings, near miss reporting, or process safety near miss reporting, PSSR. So this is the employee participation, which is giving in the screen in the right side in the down third row. So similarly, any incident happens, the investigation, or maybe mechanical integrity parts with respect to preventive maintenance, calibrations, inspection for the reactors or atmospheric pressures, storage tanks with respect to a solid, acid, chemicals, or maybe pipeline which is there, could maybe, or maybe stack lines, or maybe walls, equipment. So whatever the equipment which I'm putting as an asset integrity part, we call a mechanical integrity. So that will be playing a major role compared to the all. This will be, we make it as a chart and will be producing with the block wise. If required, there is a product wise as well. So simply, we are training them in shop floors, process safety. I mean, we train. So we train on process, we train on equipment. Again, we'll give an hazard communications, particularly with respect to process. And this may be a classroom or a toolbox talk to the for contract or maybe employees. So this captures 9, and another one is emergency preparedness. So whatever the emergency shutdown, mainly process safety concentrates on emergency shutdown. In case of runaway reaction happens, what need to be done? That shutdown procedures, on-site emergencies, off-site emergencies, evacuation plans, assembly, ERT, and mutual aids. So out of 14 elements, we drafted this, started working on this. So based upon these 10 elements out of 14, the remaining 10 elements which I'm showing in this, hot work permit, contractor safety management, and compliance audits and trade secrets. Out of 14, this 4 are, I think, other than this 10, whatever we have shown in the last screen, we captured 90 plus percentage of the data to be gathered during the process safety management were implemented with respect to the OSHAs. So this is the standard way. So that we do it. And then we started again gap analysis with respect to global. Then definitely, I am sure that you will reach the best standard of global wherever CCPS or OSHAs, you'll meet all the requirements and you will avoid the instance with respect to any process or man, machine, material, any kind of the issues you can avoid in this case. So which I've shown in with respect to OSHA's PSM approach, and this is the CCPS. So this is a CCPS part. So the standard, whenever you choose it, so we use CCPS and OSHA, maybe almost similar, but CCPS having some few more elements, elaborately split it into 20 elements in this case, based upon your commitments and chooses. There's a little bit of, thought as a bigger one, but easy only. You can, which when I was in Pfizer, I used to follow the CCPS standard, but now in India required because they need is, a lesser one, the more quantity OSHAs we prefer for the pharma, chemical, or any manufacturing industries, it will be chosen as this part of your process safety management. Before going to this, I just have there are the small story, Chota Bhai, Bada Bhai story, sir. I think everybody is listening to the story. I think Chota Bhai, Bada Bhai, a lesson in a safety culture. This Chota Bhai is a very naughty guy, and he was, intentionally asked many things. He's very curious to learn that this Bada Bhai was very intelligent to answer his questions. Chota Bhai asked Bada Bhai, Bada Bhai, what are in-process safety challenges? What are in-process safety challenges? In we call in Telugu, edurukuntunna savallu enti. क्या क्या सवाल है इसमें अपना प्रोसेस में क्या क्या सवाल है so simple way what are the in process safety challenges I'm not telling you what are in process safety challenges in process safety challenges so the question itself is a very typical piece this Chotu has asked so immediately this guy said in process safety challenges yes I'll tell you the few things we have in process industries we have in process safety challenges number one I'll say, sir, when I'm handling high hazard chemicals like shock sensitivity materials like azides, explosives like TNTs, or friction sensitivities or water resistant reactive hydrides, or metal pyrophoric chemicals or flammable solvents or corrosive cyanides and potent compounds. If I do anything, I'll maybe get affected, or maybe it may be affect my material process, or maybe man, machine, material method. This will all get affected. So he's asking that Chotu is asking. So immediately, Bada Bhai Puja is told that these are the few hazards. So one more I think challenge when we do it: handling of high energy reactions. See, diazo reaction is unstable. Grignard reaction is again very dangerous. If you dose it, for example, in the first lot, if you dose it 5% means okay. If reaction carried out, okay. A reaction is not happening. If you want to put it some more 1% also, the reactor may explode, may disaster might happen. One example I'll tell you, the company name called maybe in Hyderabad. I don't want to name the company name. There was doing a Grignard reaction. They are doing since years, almost more than a decade. They're manufacturing, their monopoly in this case. So they are doing it. They have just increased the batch sizes due to the requirement of the client. They don't want to split into two parts to save the time. So they increase just 20% of the reaction. So immediately, I think during the reaction, they started doing it. The reactor got pressurized and got exploded. There is no plant, completely destroyed. Almost side by chemical industries got damaged. All the glasses got damaged. A huge explosion happened with this Grignard reaction. Nitrogen, some chemical industries, they almost banned this benzene and nitric acids like that. So handling of high energy reactions like thermal pressure risks, which is there. So they are very risky, or we have in-process safety challenge in this. In this case, distillation particularly, in our process distillation. If you know that dry distillation is very dangerous, everybody knows it. So, but in few cases, like when you handle peroxide content, it may not be a dry distillation. Peroxide content distillation, very dangerous. It forms peroxides. If you ask me, THF is one of the solvent, or maybe any ethers are there, MTBE ethers are there, or maybe diazo, or maybe thionyl chloride. I'll tell you one distillation, one instant in this case. In one of the in Hyderabad as well, there was a distillation activity going with thionyl chloride. They are doing distillation. The reactor capacity is 3 KL. The capacity is up to filled up to half or more than half, 60%. They want to distill almost 80% of the whatever the content. So that takes almost more than 12 to 14 hours. The operator thinks, oh, I need to distill this for 12 to 14 hours. Why? So the distillation temperature of this thionyl chloride is almost 60 degrees. But the decomposition temperature of this thionyl chloride reaction mass, which is having is at 85 degrees. So what he has done is to make sure that fast distillation, the operator has given a small jerk in the steam. So jerk means whatever the in the jacket that has to move out, and the new which utility has to come out, and then again another utility which are providing a hot water, it has to come back to this reactor jacket. During this process of 5 minutes, in a small jerk, the temperature has shooted up to 60, 65, 70, 75, 80, 85. The reactor got exploded. Simple way, the temperature due to the steam for 3 kg LPS and 3 kg LPS of steam, low pressure steam, will give up to 130 degrees of temperature. Everybody knows the steam table for 3 kg, 132, 4 kg, 140 plus temperature will give. So the reaction mass was not stable, then the distillation case particularly. So there was an issue with the distillation one. So this is, we have in process safety challenges. Yeah, I'm sorry, sir. Yeah, coming to the part of the another challenge we have is pressure reactions we have. So pressure reaction with respect to hydrogenation, CO reactions is a challenge. Handling utilities. So the handling utilities is also one of the bigger challenge to cool adequately. Timely, if you're not provided cooling for the exothermic reactions, again, it's a bomb. Powder handling. Cross contamination, improper. See, one explosion happened in this in one of the company in Hyderabad in a pharmaceutical. So they are doing this is a 24th batch. 24th batch, the reactor is empty. They are charging some chemical into the reactor, some powder into the reactor. So they have not cleaned properly. So I'm going fast little bit. If you are able to, I mean, if you are okay, then that's better. Otherwise, I'll make it some slow. Okay, so the thing is, I mean, they are doing charging material. Yeah. Sorry, sir.
Go ahead, sir. Go ahead with your
yeah. So in reactor particularly, so there's an empty reactor. That is the 24th batch they are doing it. That an empty reactor, they're charging 24th batch. Almost they charge 13 bags into the reactor. The 14th bag we got it during the charging of powder into the reactor got exploded like anything. Entire building got collapsed. It is assuming that we went for an investigation particularly. Then we came to know that after this, the contract casuals generally cleans the reactor. So after his cleaning, he says, okay. So once he says, okay, supervisor will say, okay, block manager will say, okay, block head will say, okay. So but like that, the signatures has carried out without checking out. So during the discharging, the reactor contained the previous chemical called toluene. The toluene is a highly resistive material. It's a polar, there's a non-polar solvent. It generates static. Already there is in a powder in this. So powder charging, there was a charge generation. The reactor got exploded. The entire building got collapsed in this, and some huge injury, and the fatalities was nowhere. So because all are runaways, luckily they are safe in this. In process, I mean, high pressure. During the high pressure reactions, generally the people want to take samples. That is one of the challenge we faced when I was in Pfizer hydrogenation process. During this high pressure only, I want to take some sample. I cannot reduce the hydrogen pressure. I cannot take it. So that kind of things in process. Otherwise, during the process, I need to open the manual or I need to do some activity. It's a challenges. Bada bhai bola hai, in process safety challenges we are facing is one of the most and highly dangerous one is human errors. See, he may do the wall partially open, partially close, fully close, charging of material, dumping of material, because maybe we don't know what happens in the background of his home, or maybe somewhere else on the way to the office, he will be nervous or maybe hurt, he may be angry. We don't know. During that, the human error may chances happening. So behavioral and no attention and judgment lapse. So due this causes the challenges we are facing in pharma and chemical industries particularly. These are the few the few in-process challenges in this. Finally, anything I think challenges the results in the fire and explosion, toxic gas release, and explosion hazards of this. So I'm just into the subject. I just not started the subject on this. Let's go in them, and after this slide, we are going to have an understanding about our real subject of chemical reaction hazards. So now that we just made that, these are the minimum in-process challenges. See, this slide will give you many people understand typical basic unit process and unit operation flows in a chemical and pharmaceutical industry. There will be a reactor called raw material charging in one reactor, which I are showing in the first one reactor. Then it comes to synthesis, where the unit operations will happen. Unit process will happen, and then we will come to the workup. The remaining, which is all our unit operations, which is there, like workup operations, organic layer, aqueous layer, distillation, crystallization, maybe filtration, drying, maybe milling, mixing, sieving, and finally packing. This is a unique typical to make you understand who are maybe not a chemical industries or more pharma industries. This will be a typical basic process, unit process and unit operation flow in a chemical and pharmaceutical industry, sir. Is it okay? Voice is audible, sir? Screen is clear?
Yes, perfect. Go ahead,
Clear.
sir. Yeah.
Clear.
Fine, sir.
Clear.
Yeah, we have not yet started the subject, sir, and please, it's a very curious one. We have not yet started the subject. So before going to the subject also, we started working on process safety package. So any new product comes, any recampaign comes, any modified process comes, or any product which are continuous product happening in the plant, it may be a chemical or a pharmaceutical industry, this package PSP, I only named this name called PSP, process safety package. First, he has to get minimum of the raw material list. He has to make a Bible on this. So the process safety package is a Bible of that entire process, that we need to do raw material list, segregation of what is the high hazard chemicals, MSDS, chemical compatibility of this with support of CRW4 software, any other software supports also well and good. Detoxification procedures of your quenching materials or deactivation methods of the process, psychometric balance and byproducts, gases related, emergency relief system calculations or local event calculations or dump tank calculations, industrial hygiene data like occupational exposure bandings or occupational exposure limits with exposure controls and recommendations, particularly if your material is highly potent. In the process safety data, you need to generate like thermal stability data, reaction calorimetry studies, powder safety studies, RMs and KSMs and intermediates and ABS. Many people ask, so I will do only API. So then my question is, what is your basis of safety? If somebody asks that, what is your basis of safety? Yes, I handle a powder. If you ask me the basis of safety or KSM, because KSM is only used in the reactor, he may not used for the powder processing. So that's the reason I'm just putting in some word with you all. Even a KSM, we store, we dispense, we charge, we stir it, again we pack, again we transport. So this lot of one powder will go under a lot of unit operations, particularly that's the required particularly powder safety studies of all known RMs. It's okay. Unknown RMs or KSMs, intermediates and APIs has to be get tested of powder safety testings and reaction calorimetry studies and thermal stability data you need to gather in a part of the PSP. You need to do the process evaluation checklist, particularly with respect to process, with respect to equipment, you need to gather the P and ID as per the standard. You need to maintain the PFDs. You need to give ABRAs, HAZOP, or maybe any other choosable tool, or effluent generation data, and coupon test which material is mapped with your reactor or not. It means if required for highly acidic acids like POCl3, SOCl2, sulfuryl chlorides, highly reactives, which are their highly acidic natures, and interlock list, and training on process criticalities, finally gas sublimation, scrubbing media, or whatever the gas liberated, acidic or a basic. So these are the few things. If you can generate more, well and good. These are the basic process safety package required for the product manufacturing in the manufacturing plant. This gives you entire knowledge of your subject, and you will manufacture with the high safe manufacturing, and your quantity will build up and confidence as well build up on your process. So, and coming to the real subject, which I'm going to have a small understanding about chemical reactivity hazards, as I committed to you before leaving this session. Before leaving this session, particularly, you will understand what is, this process safe or not. That we are going to have an understanding about this session. So again, this Chotu and Chota Bai and Bada Bai came into picture, and they're asking that Chota Bai asked again to the Bada Bai, any thumb rule for storage. So I think this I have removed it. I'll come back to this. So these questions are, I think he's asking that how to know my process is safe or not. How to know my process. This Chotabai is asking to Badabai, how to know my process is safe or not. The simple question, even though you may ask to me or you may ask to the experts of process safety, stating that how to know my process which I am manufacturing in the plant in a reactor or a maybe continuous reactor, it's safe or not with respect to chemical particularly. So immediately, Chotabai, so how to know my process safe? Badabai has said that, Are Dada, I'll tell you one thing. If you stand in front of a reactor and ask 5 questions, Panch Pataka, we can call it as Panch Pataka, 5 questions to be asked standing in front of a reactor or maybe a reaction which is happening in the R&D, you stand in front of and ask these 5 questions, this Panch Pataka, you will come to know that this process is safe. Simple way, the first question, before going to this first question, this is just to make you understand, in world, how many processes are there? Just to make a note, stating that in world, it may be any country or anything, in world, how many processes are there? First question. So if there that, which type of process it is? In world, there are 3 types of process which is there. One is batch process. Second one is semi-batch process. Third one is continuous flow process. Simple way, I'm just coming to the batch process, stating that batch process means, if you see in the picture, no need of explanation in this literature as well. See, if you are cooking on a rice in a pressure cooker. What we will do in pressure cooker, we will add water, we will put rice, and we'll put some salt and we'll fit it and we'll heat it. Simple way. All the reactant fit into the reactor at the beginning of the process, and the products are removed when the reaction is complete. Simple way. So similar way like pressure reactor, we'll add A plus B plus C plus D and we'll fix it and we'll heat it. Simple way. That kind of process is called as a batch process. Second one, which is like semi-batch process we have. In this semi-batch process, similarly, to make you easy understanding, like when we do any curry, you take it, we'll heat the pan, we'll pour some oil at different temperature after heating. After heating, we'll put some onions, michi, something, whatever, X, Y, Z, we'll do it. So that means a semi-batch. So you're doing it. Any semi-batch process, which is a reactant that periodically added. So I'll add at certain temperature, I'll remove, periodically added, or products are periodically removed. Whatever I wanted, I will add it. Whatever I wanted, remove it. So it removed. This books define semi-batch process are neither batch or continuous. A simple way, whenever I want a different time, I'll add it. Whenever I want a different times, I will remove it. Simple way, curry. So I'll put it some masala, whatever the items we generally put it, vegetables one by one. So whenever do it, a periodically addition we call as a semi-batch process. Like I will add A plus B plus C in reactor. I will slowly add D into the reactor. Addition of D into the reactor for certain hours. Simple way, I'm just making you understand before going to the subject of the process safety activity. So there are 3 types of process. Out of these 3, there is a continuous flow. Like if you see that there is a 2 beakers and going in a same flow, like continuous flow process, whether these 2 inputs which are going from the beakers and the output from the reactor constant, there are flow is constant. The reaction we call as continuous flow process. Out of these three, if you ask me very straight, which is safer one? Which process is safer? I told you the first question you are noting. This first question is how many processes are there in the world means there are three processes. But now question in front of standing of your reactor, which type of process it is. So it is whether it is a batch process or semi-batch process or a continuous flow process. So if you ask me, the continuous flow is very safer, but in many almost out of 100, 95 to 98% of the manufacturing comes into batch or a semi-batch. So these two only decides. Again, we'll question which process safer, batch process, semi-batch process. I'll tell you, semi-batch is the safer, where I can control my, whenever I want to add, I'll add it. Whenever I want to stop, I'll stop it. So that's the reason it is declared as per the Stossels criticality class. Francis, the book also is saying that semi-batch are controllable. We can control the reaction as well. The first question is over which type of process. So that is first process is batch process, semi-batch and continuous. The second one, the second question before asking you, in world, how many reactions are there? In world, how many reactions are there? Some people that said there are two reactions, exothermic, endothermic. So some people told me, sir, isolation, methylation, hydrogenation, oxidation, whatever they are telling in the hundreds of reactions we have. See, we don't know. So a person who is standing in front of a reactor is an operator, doesn't know that which kind of reaction is going on, which process going on in the reactor. As per the, this question which is going, which type of, second question is which type of reaction it is. As per the chemistry point of view, the question is, please note this point. Second question is which type of reaction it is. So as per the chemistry point of view, I'll tell you now. The next slide will come as a process safety point of view to make you understand, standing in front of a reactor, oh, this is this kind of reaction, so I can predict this. The second question is very easy. In chemistry point of view, there are four types of chemical reaction. One is synthesis reaction. A plus B, if you add A, if you add B, A to B, it gives AB. This kind of reaction we call a synthesis reaction. The decomposition reaction, AB, if you heat it, it will break up and gives AB. So complex substance break down into two or more complex substance. These are reverse or a synthesis reaction, decomposition reaction, which is that. And third one, which is the single replacement reaction. So that means A, you're adding to BC. So then it will become AC plus B, single replacement. And fourth one is double replacement. That means AX, you're adding to BY. So this will exchange AY plus BX. If you see that, what are the formulas, which is the magnesium carbon. So that again, it is added to H2HCl, gives magnesium chloride plus H2CO3, sodium carbonate. Simple way, in this, the chemistry point of view, there are three reactions point of view. But with respect to process safety point of view, as I told you, there are two processes. One is semi-batch and batch process. In majorly, maximum, in out of 95, 90+% of will act as a safe semi-batch process. In semi-batch, there are three types of reactions again. Guys who are listening this session, again, I'm telling, this kind of literature, you will not get it anywhere. This completely is in a, knowledge driven. We have proven in thousands of reactions which you conduct in the process safety and not by me, and thousands of reactions happening in the many and all over the world, and Stossels also giving a clear that this type of reaction will comes into this kind of reaction part. So in semi-batch, which I have told you semi-batch, so please be keen, standing up in front of a reactor. First question stating that whether it is a batch process, semi-batch process, or continuous process. First question is clear. Second question, which type of reaction is carrying in this reactor? So this is maybe which type of, so in semi-batch, instantaneous reaction, which I mentioned in the screen, if you see that, it may be called fast. I'll explain you. Before, I think after this completion of 5 questions, you'll definitely understand, oh, this is an instantaneous reaction. This is a fast and dose controlled reaction. So second type is accumulation reactions and delay type of reaction. What is this? Let me have in the next slides, we'll understand what is this instantaneous. So what is this accumulations? What is this delay type of reactions that we are going to have an understanding about. This chemical reaction hazards, all over the world is same. In the world, anywhere you go, any country you go, the same will happen in this. Okay, the same reaction. So this is applied to all of the world. This data is literature as well as the practically proven on that. Batch process, as I told you, everything done, you heat up. That's it. That process we call as, and again, batch process, energy release during the heating and maintenance. So now coming to the part of this, if you see this is a real graph which I captured from the reaction calorimetry, which I have shown in the earlier slide. In the second question, which type of reaction it is. So out of three, which is instantaneous reaction, accumulation reaction, delayed initiation of the reaction, that I'm coming to instantaneous. First reaction which is there, it is instantaneous reactions. If you see the screen, as soon as addition starts, this is the graph. You see the graph, the green color mark which is there, this is an addition with respect to time. At so and so time I started addition, at so and so time I stopped the addition. As soon as the addition, so if you see the graph as well, I'm just highlighting this, a laser point. So this is the addition time, addition happening over the periods from so and so time to so and so time. As soon as the addition starts, heat generation seen in the isothermal calorimeter. It's a real graph which I've taken from the calorimeter, stating that once I started, what I addition is hydrogen peroxide I'm adding into the reactor. During the hydrogen peroxide reactor, immediately there was an energy heat generation can be seen. Now, if the pink color which is mentioned is a heat of reaction. We call it overall enthalpy, but I mean heat of reaction. As soon as addition stops, heat generation stops. So then whatever the heat generation produced, we calculate it here. Oh, this is the heat generated. That will be calculation and given to the people. That will also will understand. So just before the second question, so this is an instantaneous reaction. I'll tell you one example as well. So just don't mind it. I'll use in a different language in this. So my friend used to take, it's to make you understand only, not to make any other thing. So I excuse Ashok sir and Jitu sir, and I'm going to explain to make the listeners to well explained about this instantaneous reactions particularly. So my friend started taking alcohol at 2 o'clock. He started it and he ended at 3 o'clock. So once he started immediately, first peg, he got immediately kick. And when he stopped at 3 o'clock, he got a kick, got out. That's it. So kick went out. So again, the similar way, I'll tell you, the similar way, 1 second. Yeah. The similar way, accumulation reaction. My friend started taking an alcohol, the first peg at 2 o'clock, immediately got a reaction which is showing under the screen. But after, I think he stopped at 3 o'clock, but remaining after 3 to entire night, he got a kick. And if you see the screen, this one particularly, so after this, when the addition stops, the heat generation does not stop, but continuously for several hours until all the heat is generated. Simple way, I added addition into the reactor. It started into the reactor at 2 o'clock, reaction initiated. At 3 o'clock, he stopped the addition, but still the reaction is going on. The reaction is going on till the night. So simple way, in our BPRs was to write, charge the reaction, KSM into the reactor and maintain for 12 hours. That kind of reactions we called as accumulation reaction. Simple way, I started adding the chemical in a reactor. So at 2 o'clock, I stopped the addition at 3 o'clock, reaction is complete. This kind of reaction we call as instantaneous reaction. Fast reaction, dose controlled reaction. That means if I drop one drop of chemical into the reactor, immediately that one drop will react and stops. If you drop 100 liters, it reacts with 100 liters and reaction will stop. Whenever, so that kind of reaction we call instantaneous, and this kind of reaction which you're mentioning, after addition also the reaction continues for several hours, we call it as accumulation reaction type. When addition starts, the reaction slowly starts to generate, right? When addition stops, it does not stop but continues for several hours. This is real data, the real graphs which you have taken from RC1MX, Metla Toledo. That is a monopoly in the reaction calorimeter particularly. If you see this graph, so no need of explaining much more to make you understand the delay type of reaction. I think chemical reaction was working in the chemical industry and pharmaceutical industry. They will understand this kind of very dangerous Grignard reactions. See, initially what I did, when the addition starts, if you see this green line, I started addition at so and so time at to consider that was at 2 o'clock. But I mean later that when I started addition, the reaction does not have any significant heat and no significant heat is generated for first 15 minutes of the reaction. If I'm seeing after approximately 15 minutes, the reaction initiated, sudden large amount of energy is liberated. This kind of reaction which we observed in the R&D as well as batches, it's a very dangerous on plant scale as a large generation of heat may exceed the cooling capacity of the plant and may cause significant rise in the temperature of the batch. This example, which I'm showing a real graph, which is Grignard, 1-bromobutane addition, first lot I added immediately. After later some minutes, I added at 840, but this laterally at 8, 9, 10 or something, there was sudden peak rise, which is having sudden of almost 63 plus degrees. That means my process temperature exactly is 65, and here is 65. 65 plus 65, almost 130. So this shoots up to when you add it within a small quantity, the temperature shooted up to 65 to straightforward 130 degrees. If you see in the graph also, this will reach up to 130 to 140 degrees is a calculated one. Sudden rise of temperatures we call as a delayed type of reactions. The same difference, you see that. So this, the same graph which is just replicated is a continuous of this one, same which is the previous slide. So after that, if you see after 10% addition of reagent, the addition starts, the reagent does not have any significant heat generation. After approximately 60 minutes, the reaction initiates a sudden large amount of release, and later the heat liberation during the remaining 90% of the release we called as a delayed initiation reaction part. So in the second question, how many reactions we have? 3 reactions. One is instantaneous. That means whatever I added in the reactor immediately reacts, reaction is over. Second one is accumulation reaction. I add in the reactor, it start initiated, but later after stopping also, the reaction starts continuously. Accumulated reactions. And third one is delayed type of. I adds at some time, laterally whenever it wish, it give a lot of energy. Suddenly that's pocket. This could be hazardous on the plant as a large heat generation may exceed the cooling capacity of the plant. This may cause significant rise in the temperature on the batch. So these are the three process which I mentioned. So second question is very clear. So first question is why I'm repeating this is this kind of knowledge which I'm mentioning on the screen. You may not get it from the many people. Why? Because this was a literally we made it in the not practical, and we got it some literatures, multiple things, and we got it, and we are trying to give it a good education to the people to avoid accidents, explosions into the plant. So similarly, which I shown in the batch process, which is all at a time I dump this green line, which is there, and I'll heat it. There will be sudden lot of energy, which you are seeing in the screen. There's a lot of energy. So if you see that I heat it, red color line, which will heat the reactor. Again, this was to be very hazardous on the plant scale, as a large heat generation may exceed the cooling capacity of the plant on due to the high thermal accumulations. This cause significant rise in the temperature of the batch. In such scenarios, it recommend to convert batch to semi-batch. So finally, the second question, which is that if you stand in front of a reactor stating asking that which type of process it is. Oh, this is a simple way. This is instantaneous reaction. If I add something, it will react. Accumulation reaction or delay type of reaction. To make you understand very easily that I had drafted like this, very easy to make you understand which type of process it is. So now, as 2 out of 5 Pataka questions, the first question as I told, type of process, type of reaction. The third one is why I'm stressing particularly this kind of, these are, you need to keep in your mind as well as something paper on paper, 5 questions you ask and stand in front of a reactor. I'm damn sure you will tell the process is safe or not. Simple way, the third question is how much adiabatic temperature rise? That means many people may not pronounce this in the shop floor because they are not chemical engineers, they are not AB chemists or R&D chemists, they are into the mainly an operators, they do a charge the material. So they need to understand. So Dada, what is the adiabatic? How much adiabatic temperature? That means how much exothermic rise? How much exothermic? Sir, my process temperature is 40 degrees or 35 degrees. So at process temperature, I add something chemical. So there in reactor A plus B, I want to add C into the reactor. How much exothermic will come? So how much exothermic rise from 35 to how much it will raise? 45, 55, 60, without 10 degrees, 20 degrees, 30 degrees, 40 degrees, 100 degrees. I have seen up to 800 degrees in my one of the batches which I observed by the calculation. We stopped the reactor and we have immediately drained out, particularly in the small jacketed reactors, which is for the reaction calorimeter. Practically we have reached up to 500 also as well. 500 means this will be not stable, but the calculation gives our cooling capacity, it will take in. So that's kind of reaction also we have experienced in this. So that is an explosion runaway only. So no need of that we are going to have a discussion in the next slides particularly. So the third questions which is mentioning is, sir, my process, if I add this C material into the reactor, in the main reactor, what we have? A plus B we have. So if I add something C into the reactor, how much exothermic? 10, 20, 30, 40, 50. So if he says that, no, if you add this, you will get 30 degrees. So your process temperature is, so now 35. Your adiabatic temperature rises again 30. So 30 plus 35, 65. So these two mix up, it will get maximum temperature of synthesis of reaction, we call it as. So now question which you are going to, third question is, how much exothermic, sir? In R&D, we have seen only 5 degrees rise of temperature, but in batch commercial scale, it is shooting up to 50, 60, 70. So we need to understand how much of exothermic the R&D person has to answer this. Third question, which is the how much exothermic rise. So one more thing to me, question to tell you. My process temperature is 60. I added some chemical that shoot up to 100 plus 100 or adiabatic temperature rise. That means exothermicity is 100. So 60 plus 100, 60 plus 100 gives rise to 160, right, sir? So 160 is your maximum temperature of your synthesis reaction, we call MTSR. We call as MTSR. So like that, for example, again, my process temperature is 20. My adiabatic, my exothermic rise is another 100. 20 plus 100, 120. 20 plus 100, 120. So that is 120 is maximum temperature of synthesis of reaction, we call it. In case of cooling failure or in case of dumping, what is your MTSR? We call it as an MTSR. What is your MTSR? Means maximum temperature of synthesis of reaction. So your adiabatic temperature is 60. My process temperature is 40. So 40 plus 60, 100 is your MTSR. I hope you understand. Third question is, what is the exothermic rise? How much exothermic temperature rise it is there in your reaction? This is the third question, the basic question it is there. And fourth question, so I'm just skipping it. I'll tell you in the last this one where it is. So as shown you that process temperature plus adiabatic temperature gives rise to MTSR. If you see in the screen, particularly MTSR, right, sir? So this part particularly, again, MTSR means maximum temperature of synthesis of reaction. For example, again, I'm telling why I'm particularly telling in this case is to make you understand the next slide. My process temperature is 30. My adiabatic temperature rise, that means exothermic is 200. 30 plus 200, 230. MTSR is 230. The highest temperature chemical reaction, this MTSR is nothing but chemical reaction mixture can reach during the runaway reaction if cooling or control is lost. So the fourth question, as I told you, the third question is very clear. Third question is how much exothermic? The process temperature is 30. So again 20. 30 plus 20, 50. 50 is your MTSR, which I'm showing on the screen on this. So fourth question is that, so which I'm explaining it to be maybe hardest part, but once you know and stand in front of a reactor and ask that what is exothermic, how much exothermic comes if I chart this 10 degrees, 20 degrees, 30 degrees. If you come to know that, you will easily calculate. My process temperature is 30 degrees here. My room temperature make a wrong. So I got an adiabatic temperature of another 60. 30 plus 60, 90. 90 is my maximum temperature of synthesis of reaction in case of cooling failure, in case of dumping. So that's the part. So in this fourth question, which I'm showing on the screen, decomposition. Sir, where is my decomposition temperature? Sir, Dada, your temperature, for example, to make you understand the decomposition temperature particularly, for example, the process temperature is 50, your adiabatic temperature rise. That means the third question, which has exothermic, is 100. 50 plus 100 is 150. If your decomposition temperature is below 150, then your reaction mass is bomb. Simple way, sir. Again, I'm telling, sir, don't get confused. So your process temperature is room temperature. That means 35 degrees. Your room temperature is, process temperature is 35 degrees. If you add some chemical into the reactor, that means A plus B is already there in the reactor. You're adding some C into the reactor. So during the addition of the C, what is the adiabatic temperature rise? Sir, there is adiabatic temperature of size of 100. Your process temperature is 35. So 100 plus 35 gives rise to 135. In 135, your decomposition temperature is below 135. We call it as a reaction is a bomb, critical class. Right, sir. So this is called decomposition, where material get highly exotherm and run away. If you see the graph, there is no disturbance on this. I'm slowly raising 2 degree per minute. If the graph, you see this, 2 degree per minute, particularly in this 2 degree per minute, I'm raising it. But there is no significance. I'm heating it. Again, it got cold. Nothing. There is no significance of anything. This is a typical graph. If you see in this graph, again, I started heating 2 degree per minute. At certain temperature time, at 100 degrees, at 100 minute, I got an issue. At 100th minute, there is an exotherm runaway. Suddenly shooted. How much it shooted? 114 degrees per minute. 114 degrees per minute. If you see on the screen, 114 degrees per minute, the temperature shooting in the reactor. So this is the decomposition temperature. Where it is exactly at 100th minute means, again, I'll calculate this. I'll put it at 180, 175 to 180. That started initiated by decomposition of reaction mass is bomb. So this kind of one of the make you understand. And the last one, so now you understand which, now you understand how much of exothermic it is and where is my decomposition. Simple way, 4 questions ho gaya. Fifth question, which is there, we call a safety criticality class. Any reaction, A plus B plus C plus D gives rise to E, whatever it may be. So which kind of class it is, what is the criticality of the class? If your class is coming 1 and 2, then it is not critical. If it is 3 and 4, again it is a critical. It is in 5, you need to redesign it. This is a safety process criticality class. So if you see this table, if you see this is the increasing order of the temperature. This is increasing order of temperature. That means the temperature is increasing more, or maybe criticality increasing more. With few examples, as I told to you, MTT is nothing but boiling point. MTT is nothing but boiling point of the chemical or a solvent. MTSR, I already told you, maximum temperature is there. This is the third question which I am asking. Already you know the process, you know the reaction, you know the MTSR, you know the decomposition temperature. Now, a small understanding to make it. So any reaction you pick up, any reaction particularly. So no, sir, I want to take it as a chlorination reaction. This is a real data, guys, who are seeing the screen. These are the real data which I'm mentioning in the screen. There is particularly one of the plant manufacturing some chemical. The reaction type is chlorination, and the DMF. They are doing some DMF addition to the reaction mass. So just we apply this. You see this. This is increasing order of temperature, right? I'll put it. Process temperature is 0, 0, 0, 0. If you see anything, 0, 0, I'll put it. Make marking of the type of class 0. Again, what is the next higher up to 0, 0, 3.2? MTSR is 0. Again, sir, the MTSR, there are mapped 2 things immediately after about process temperature. What is the next is it is 39.6 boiling point of the DCM. Immediately boiling point of this one, MTT, which is there. Again, decomposition is not there up to 20. Maybe there, but more than 200, we are not predicted it. So immediately we got it. If you see this class 1 reaction, which is mentioning this one, class 1 reaction. Again, to make you understand, again, another reaction called maybe acidification or Wilson reagent preparation. Example, is a Wilson reagent preparation. There is addition of POCl3, highly acidic nature, right? Again, we'll mark it. The process temperature 0, 0, 0, 0, 0. Immediately after, what is the higher one? Boiling point, which is there, 61. Immediately after, oh, this is MTT. This boiling point is there immediately. There are two mapped. What is the next immediately? The thermal onset. That means thermal onset, which guy is TMR ready. This is a class 4 type of reaction. You see this. This is a class 4 type of reaction. Simply, these 5 questions, Panch Pataka will give you answer. Oh, this is batch process. First question, type of process. Which type of process it is? Batch, semi-batch, continuous. Second question, type of reaction. It may be instantaneous, accumulation, and delayed time. Third question, how much adiabatic temperature rise? That means exothermic. How much it is? Fourth question, where is my decomposition temperature in this? At what temperature the material get decomposed? Fifth question, what is the criticality class of this reaction? So these 5 questions makes you understand what is your criticality, whether your process is safe or not. A simple way, you may not be a chemical engineer, you may not be a chemist, you may not be a R&D chemist, you're not a scientist. Simply apply these 5 questions standing in front of a reactor, ask this Panch Pataka questions. Now you can declare this process is safe, this process not safe, that we can do it. So this is a simpler way. If it is a 1 and 2, safe, 3 and pro, critical, and 5 is you need to redesign. So more the scale up from lab scale to commercial scale, the risk will be always be higher case. So this is 5 triangle. This is 5 triangle particularly, as I mentioned to you. So this is 5 triangle and explosion. This is a pentagon, that's explosion. And this is a deflagration rhombus and process safety triangle. I'll go a little bit of faster. So this make you understand, to make you understand what exactly it is. So difference is, so for happening an explosion, particularly for dust explosion, you require this 5. So that means oxygen, fuel, heat, and it should be a confined, and the material has to disperse. Then only explosion happens. If it is not confined one, particularly if it is not there, that means material only will have deflagrate, but this will get, dust cloud formation will be there, disperse happen. This gives black particles during your milling, mixing, blending, packing, whatever activity. There was a material already got deflagrated. So that kind of things, minimum understanding about dust explosion severity will be there. Understand. So this is a basic 5 triangle. This is a dust explosion pentagon. This is the rhombus, which is the deflagration. This is the process safety triangle, which is mentioned on this. Process safety triangle, if you miss anything, inadequate knowledge of any reaction rates, plant capacities, or chemical potentiality, you need to know, lead the process to fire or explosion to spill or explosion may happen on this. So a small video based upon, if you see this video, you will understand your process is safe or not. You will get it in this case. Simple way, a simple video, and we can slowly conclude the session. So you will understand this process is safe or not. Yeah, 1 second. I'm just coming back to, I think guys, you are seeing this video, I think. So I'll not play much time, but to make you understand something easy. So just putting, I think the audio is also is there. Audio, I think whether if it is not audio is not audible, please let me know.
No, sir, audio is not coming.
You have to select computer audio while sharing in the advanced portion, but it's a self-explanatory, sir. It's fine.
Yes.
Yeah.
Yeah, just coming to the subject. So we have with a little bit of faster I'm going on this case. So we have done, I think we understand this. So now, if
Yes,
you
we
see this instance, there was an incident in the Jackson, Florida, USA. Yeah, it's clear, sir. It's clear. Audible.
yes,
Audible
go
and
ahead.
visible, sir.
Yeah, go ahead, sir.
Yeah.
Yes.
So let's go. Yeah, fine. So if you see this video, if you know this, which type of process it is. So now first question is, which type of process it is? It's a batch process. All I dump it into the reactor, I heat it up to 300, 400, and again its exothermic is up to 360. It is not controlled. Another question to you all, what is the difference between exothermic and runaway? So exothermic is which exothermic sudden rise of temperature which can be controlled. It is in my hands. So that is an exothermic. Runaway means with the sudden rise of temperature which I cannot control. That simple way, the difference. That's the reason we call it as a runaway reactions. So particularly which type of process it is. So now based upon this process, we see that batch process we are happening, right? Batch process. What is the reaction name? So in batch process, only one reaction time. That's the reason I want to mention this metal exchange, hydrogenation like a metallization. So how much of exothermic amount of release? They don't know it. The energy liberation, they don't know it. How much cooling capacity they require, they don't know it. How much, what is I mean MTSR? MTSR means what? Maximum temperature of sense of reaction. How much it shoots, they don't know it. See, MTSR is nothing but in case of cooling failure or dumping of materials, the temperature shoots to certain temperature. This is called maximum temperature of sense of reaction. So that's they don't know it. So that means how much exothermic, they don't know it. Where is the decomposition? They don't know. Simply, what is a criticality class? They don't know. If they know this basic 5 questions in these reactions, yes, I know this is a batch reaction. It's a metal one. The exothermic shoots up to 400, 500, 600, or maybe decomposition is nearby 360, 370, or maybe decomposition occurs in this case. What a criticality class is 5. So if they know it, 100% they used to avoid this one, even though they're advanced in this. But this is the basic Panch Pataka, which are 5 questions. If you ask standing in front of any reactor manufacturing, chemical or a pharmaceutical industry, that will give a glimpse of understanding about your incidents, and you predict this, your process is safe or not safe. The simple way, the process safety strategy with respect to testing also. If you have a powder, whether you need to test explosive, then stop. If it is not explosive, then don't go for dust explosion analysis. So explosive testing is different, not explosive testing is different. If you have dust explosion testings, again, whether is powder is dust accumulated or not. Then it is coming to the part of that whether it is cloud formation is there or not. If it is even the cloud formation, it's coming explosion or not. Like that, this is a sequence of studies which I'm showing, which is captured, which is gathered from the chill earth during this, because we have done thousands of powder safety testings in my past experiences where we predicted any dust experience characteristics. So a little bit of faster I'm going, but this is the subject which we have to predict this process safety strategy, but particularly powders and dust explosion studies. So if you see this, I'll go a little bit of faster. Explosion severity. Last video, which is there, if you see this video, you will understand what is the impact of the powder, even though the fist of material, maybe 10 grams or 50 grams or 100 grams, the explosion which will give that you can understand. Please let me know anything sound is missing, or maybe video is stuck up, or please. This final video, you can see this. Very clear understanding about the dust explosion severity, which is there. So they started.
The video is getting lagged.
It's clear, sir, now?
The video is clear,
It's
sir,
clear,
but
sir,
sound
now?
will not be. Yeah. Go ahead.
Listen,
Go ahead.
there was a dispersion happening. The dispersion is happening now. So dispersion happened. So only powder they dispersed. That's it. In a open, not confined, they dispersed. In open confined, there is no confinement. They just disperse. This is a dispersion. When we throw sand in the air, the dust particles will come the similar way. Just important. In the dust dispersion, we just ignited something when they disperse. There's a small quantity which is there, 10 to 50 grams. The dispersion happens. This, if you see the video, the dispersion was happened. This we call deflagrations. We can also call deflagration. A similar way when it is in confined, fine confinement, not completely. If you see this, its quantity is very less. There was with the powder dust dispersion is a confinement. Again, small explosion was happened. If it is another scale, again we put it the same quantity of material and we can close it tightly. If you see this, complete tightly we have done it, sealed it off, and now there was a dispersion. They started it. So to make you understand about the dust explosion severity, see this video. So that's the way to make you understand the severity of the powder. So this is the one. And coming to the subject, yeah. So yeah, this is so and a small clue is a small unstable material which is having a decomposition temperature less than 120 or 150. That is not right to store more than some days, 1 or 2 days. So if it is less than 150, very strong reactive, temperature control only, we have to store it. Don't store in a room temperature. That's maybe a time bomb. Expired or unstable chemicals can turn into a time bomb. So that's it. So this is the basic understanding of chemical reaction hazards. Anyone can stand in front of a reactor or any pod, which I explained today. So ask 5 questions, Panch Pataka, process, reaction, exothermic, fission, and class. There's 5 questions in front of a reactor, and you will understand 100% of your severity, chemical reaction hazards. You can.
The time is up.
Yeah. Okay. Let me share my screen.
Okay.
Dinesh ji. Okay, thank you, Dr. Hari. It was a wonderful explanation, clear understanding with the Chota Bhai, Bada Bhai, Panch Pataka. What a wonderful explanation. I'm sure after this, anybody will have any questions, but I request Mr. Dinesh Paul, you have any questions received, sir?
Thank you very much, Ashokji. So far, I didn't receive any question in the Zoom chat because of our audience were so inspired with the speakers. They were concentrating on the presentation. So, but it doesn't mean that we can give opportunity 1 or 2 questions and who sure they have. Let me them allow to raise their virtual hand, and so we can acknowledge your question, and our presenter, Dr. Hari Bukia, will maybe answer your question or clarify your queries. So, Ashokji, you can remove the share screen from mine so we can see the audience if anybody raising the hand for the question, but be very limited since we are also running very late. So first question raise hand by our Mr. Shiva Prasad Rao Chetu. Please, you can unmute yourself and directly you can ask your question. Ashokji is the presenter in the meeting room.
Yes, he's there. He's there. I'm putting in the spotlight. Yes.
Yes.
Okay.
Sir, good morning, Hari sir.
Good morning.
I am from actually I'm from India, Visakhapatnam. I would like to know only one thing. See, the explanation is very good, and especially as a non-chemical engineer or non-chemical diploma holder, how we can understand all these things, because you have explained in a different all these things in a very beautiful way, because that gives the starting point to the non-chemical engineers. But as a professional, and to start with, I think these all the things are good for the medical pep talk. What we say in other things, basic pep talk every day, what we are doing. In that this comes, but the training is very necessary in this. And with that aspect, I would like to have some more input, sir.
Definitely. So please let me know that what you exactly question you want to understand, which topic you want to understand. Please, you can access my number or maybe mail ID. You can send it to us. I'll make you understand the presentation as well.
Okay, sir. Thank you. With respect to the temperatures, the decomposition temperatures,
Yes, sir.
you had that particular point, because
I'll
all
tell you
others are
one.
good.
I'll tell you
Follow.
one secret of logic particularly. If your process temperature is, for example, in your reactor particularly, say decomposition means it generates heats. Degradation means that material got degraded because of the quality impact. There is a two difference are there. So degradation not happen. So decomposition happen. That means when decomposition breaks, like AB gives rise to AB, like two different split is off. So that's it. Decomposition. First question. First point. Coming to the point of in real subject of during is, as I mentioned, the decomposition temperature, your process temperature, as I mentioned, for example, giving an example to make you understand, your process temperature is the RT, room temperature. That means 30 degrees. You consider 30 degrees. Your exothermic temperature, maybe your exothermic rise, how much it is? Maybe 100 or 200. Consider as 200 degrees. So 200 plus 30, it's a MTSR is 230. So now MTSR means maximum temperature of sense of reaction. In case of cooling failure, or maybe in case of dumping of a material into the reactor, sudden dumping of a reactor, instead of slow addition, the temperature shoots up to 230. That is a MTSR. By mistake, your decomposition temperature observed in the experiment stating that below 230, that means it may be at 180, 190 or 200, anything below that, we consider that reaction is very dangerous, critical and bomb. I hope you understand. I hope you understand. So the temperature identified from the process safety testings like ARC, RSD, DSC, the some instruments are there. We predict that one. We get the data from that, and we tell that, oh, your decomposition temperature is what at 180. So your MTSR is 230. That means your reaction is critical. That's the way we predict this one, your critical reaction or not. Hope you
Right,
understand.
sir. Thank you very much. It's very clear. Because of your speed, I could not able to get your first sentence in the explanation itself. Thank you.
Yeah,
Thank you very
yeah,
much.
yeah. Okay, sir. So due to some
Thank you.
signal issue, maybe I may not. That's the reason I disconnected. And again, I not automatically disconnected, and I joined in the mobile. So you can ask the questions. Not and so anything from with respect to process, dust explosion parameters, dust hazard analysis, or maybe there's a very cue. I mean, which I am explaining in a simple way, making you like a Cerelac, making to understand you. To feeding this one to your brains, this will give very easily. So maybe many people gives a lot of explanations, but after getting hundreds of testings we did it in the lab, or maybe assessments we done in the plant, or maybe we have trained on this particularly the logics way we understand the chemicals. That's the experience we have to make you understand. So that's the reason I'm trying to get you the simple way, the simple five questions, or maybe even the dust also, just deflagration and detonation. That's it. So you need to understand it. So that kind of simple way explanation, I made it. You can ask questions also, sir. Any over to you, sir, please.
Thank you very much. Thank you. Ashok
Thank
ji,
you,
you were
sir.
saying
Thank you
something.
very much. Very clear.
Thank you very much. And let's, yeah, I think we'll go ahead with our continuation of our agenda items. So before that, I request Mr. Jeetu. Thank you, Dinesh ji. We'll come back to you again. Yes, let's talk about Mr. Jeetu. The time to recognize our wonderful speaker of the day.
Thank you, Ashok ji.
Yes.
I won't take much time, but this was an outstanding presentation. And I only would say that the testimony is that Dr. Hari is closely associated with Accutech, David Moore, who is a personal friend And Ashok and I, we both have invited him few times in Bahrain and Kuwait and so on and so forth. Personally, he is my dear friend, and family-wise, I'm very closely associated with him. I went to even Baltimore, and he hosted me enormously. So that is the biggest testimony. Second one is, he also, during his presentation, showed the video where Gary Vischer, who was appointed by President George Bush, and he had to go through the Senate testimonial questionnaire, and he also was invited personally by me, for which I had to take permission from President Bush, and he came to Bahrain, and we spent 7 days together and became very close friends. So these two are very closely really a testimony of Dr. Harry's profound knowledge. And I was very much impressed, Dr. Harry, the approach you took about Chota Bhai, Bada Bhai. That was outstanding, the way in which you really educated all our delegates on this webinar. And one or two things I can just highlight, in which you had MTBE, which was the replacement of the tetraethyl, tetramethyl lead, organic lead compounds, which were used as the additives or for gasoline. And all the chemistry involved during the presentation, I can only say this, that the basic of loss prevention with fundamentals involved is a must. And you educated people how important it is that chemical reaction are the major contributory factors on disastrous situation, whether it is the chemical industries or pharmaceutical industries or oil and gas. And when I say oil and gas, many pyrophoric material have caused even super tankers to sink into the Gulf Sea, where Ashok ji is right there present. And during my young days in the 70s, I have witnessed and participated those super tankers sinking, and root cause analysis showed it's the pyrophoric material which resulted. So, Dr. Harry, all I can say is that the people should understand, and people like Jayanti ji and our very dear new friend Jivan ji, they can teach us all about stoichiometric reaction and adiabatic compressions due to exothermicity. These are very key terms that you used during your presentation, and it is not easy to understand unless you go through the fundamentals. You showed about dust explosion. I personally lost 2 plants. One was the sulfur pleading plant because of the collision of the sulfur pleats causing the dust and eventually ignited by the static electricity, and we lost the 3 plants under Saudi Aramco's jurisdiction, and similarly the flour mill. So point here I'm making is that your presentation was outstanding, very informative, very educational, and I think you covered the 15 days full-time workshop in just about an hour and a few minutes. So my hats off to you. You deserve this complimentary thank you with gratitude
Let's give a
to
big
Dr.
claps to our
Harry.
guys. Virtual
Absolutely.
claps.
Thank you, sir.
Yes.
Beautifully done, and we are very grateful to you. One last request to you, if we may. Besides this presentation, we, as you heard Ashok ji, we have e-newsletter, and if you could submit the article or more than one articles, we will be very happy, because your subject you dealt with is very dear to us in our heart. I'm a chemist, I'm a scientist, I have done a lot of research on most of the things you covered, and I really would appreciate, for the benefit of our all delegates, not only that, this will go around the world, and I think you will be able to help industries, whether it's heavy chemical industries where I did a lot of work, and also pharmaceutical, oil and gas, and many others. So with that, pranam to you, and I think we can only say thank you very much,
Thank
sir.
you, sir. Thank you very much. Thank you, sir. Thanks
Thank
a lot.
you, Dr. Hari, and appreciate Jitu Saab for recalling your old memories and other things. Thank you, Hari, for sharing the knowledge. The purpose of whole of our foundation is this: giving back. You have so much of knowledge. It's almost 10:30 in India. You came and delivered such a wonderful session. And I see the participation because we are running out of time. But I said, let's not disturb because so many people are there listening to you. So we have a very important announcement as well. So thank you very much. And please keep joining our OKT sessions. And please do share in our WhatsApp hub also if any questions are coming. Thank you again. Thank you.
Sure, sir. Thank you, sir. Thanks a lot, sir. Thank you very much for giving opportunity, sir.
Sure, sir. Thank you so much.
Thank you,
As
sir.
I said in the beginning, there are scholarship programs. We have so many students on the call, and this is a student scholarship program which are being, we announced on the last month, but these are the students which got the scholarship recipients in 2025 from different colleges in India, Tamil Nadu and Telangana. And of course, we will ensure that AP also gets participated this time. This is our scholarship chair, Mr. Dr. Krishnaswamy Ramanathan, as well as our Dr. Lakshminarayan Prodhuchur. They are facilitating the scholarship program, Mr. Dakshinamurthy from Tamil Nadu. And this is the announcement. We made it on last OKT session, 17th June. And until 31st August, you can submit your nominations or petitions. And by 30th September, we will be reviewing, and on 31st October, we'll be announcing. These are the scholarships being patronized by Dr. Praveen Patel, Mita Patel from Arizona, and Dr. Dhruti Thakkar from New Jersey. So please do watch out our this flyer as well as our website for more information. Now, this is another important activity we are doing today, launching of AP Chef, a Andhra Pradesh student HSE fraternity. We have a vision, mission, as well as Panch Pataka also there. So I just want to. So this is available in our website. I don't want to go through it, but I'm going to open the website and clearly show what are those Panch Patakas. And these are our AP Chef advisors, Mr. Jitu, myself, and Madhu Bura is our chair, Community Corporate Engagement, who is sitting in Vizag, and Mr. Lachaya Jayanti, who is a very inspirational, active leader. He is the backbone of AP Chef, I can say. He has already mobilized so many students. I request all the students who are participating today to go to our website, click the link. I'm going to show you what exactly how it looks. Okay, this is the AP Chef website. So there is a vision to develop ethical, competent, and socially responsible HSE professional committed to lifelong learning, professional excellence, and giving back to society. That's about AP Chef vision. The mission is to empower HSE students through mentoring, networking, professional development, volunteering, and leadership opportunities while fostering a culture of service to the HSE profession and the community. Now I'm talking about Panch Patakas. Number one is professional development. That's what we do under the AP Chef. Number two is building professional networks. The networking is so important, gentlemen, nowadays. If anybody attends an interview, they will only ask you, apart from your college, how many professional networking associations you are a member of each. So that's very important. So you need to take part in the professional organizations, giving back to the profession. That's what Dr. Hari has done. That's the aim of the whole our foundation. Leadership, ethics, and lifelong learning is also one of the Pataka, and mentoring and career support, the fifth one. So these are our things. And if you want to join in this AP Chef, it's absolutely free. There is no membership fees at all. And you can click the Word form as well as a PDF form. You have the information about your college, your information, your personal information like a mobile number or WhatsApp number. And again, of course, this foundation is running on a charity basis. Again, giving back. If at all you want to give back to the foundation, you're welcome to do that. There is no limit. You can 1 rupee also is a fine, but there is no limit. There is no mandatory. So you can join the our particular AP Chef. This is the AP Chef enrollment form. You can just go through that: photograph, name, mobile number, academic, what you are studying, professional interest. So this is a very simple form which you can fill it either by handwritten as well as you can also download the Word form. There is a website, there is an email ID at the bottom. You can just fill up and send it, send it to that email ID. This is a voluntary contribution. It's absolutely no mandatory. You can join freely and get the services and give back to the community. Absolutely no mandatory requirement. You just fill this, and this is for office purpose. It is Mr. Madhu Bura and Mr. Jayanti Lachaya. They both are the conveners of AP Chef who are in AP itself. So that's about our. I understand Mr. Madhu Bura is a little busy in outside, but I request Mr. Jayanti Lachaya to say a few words, please.
First of all, I thank on behalf of everyone, whoever student member, our principal, and convener of the curriculum coordinator, Mr. Varahalu, Dr. Varahalu, and all here. And we are thankful to Jitubai as well as Ashok Garlapati. On a specific time, I think that day the muhurt is good. When I asked, they promptly responded, and they created this website and form and everything in very short time. It never happened because I too worked in Gulf and all for 25 years. When we say some proposal, they say Inshallah. We know the meaning of that. So that not happened here. Really, it happened. I thank wholeheartedly on behalf of Madhubura, myself, and Government Institute of Chemical Engineers, Vishakhapatnam, Principal Sir, and Varahalu. They are here in the group. They must be listening also. We are very thankful to you, and we will write a letter also on behalf of the JEC. And our students are there, they are listening, and all the explanation what you have given, they'll fill the form. Okay? Thank you, sir.
Thank you.
Once again.
Thank you so much, Garu, and appreciate Madhubura Garu, and of course all the principals as well as the department heads who are on the call. We would like to thank everyone. This is only a little part we are giving. We are just establishing a platform to give back. We have so many mentors in our foundation, and you said website creation. It's all voluntary again, and it's Mr. Sheikh Makbul from our own Anantapur district. Yeah. He developed this website within a short span of time, web page, and we would like to thank him also. As I said, we have so many mentors, but I want you to introduce one mentor for the benefit of the students. How communication is so important nowadays to excel in your profession. So, as we Indians, so much of knowledge, but we fail in communication. We fail in expressing ourselves. Today, I invited our friend. He's a HSE professional for many years, and he's also chair in our foundation for communications and leadership skills. So when I shared this proposal with him, I invited him today to talk about importance of communication. Mr. Dinesh ji, please go ahead.
Thank you very much, Mr. Ashok Garlapati ji, our Jitu sir, and all other the audience. Even it is the very late, and in India, I think over the 10:30 above. But have a patience, and I will finish quickly. This is the important session as Ashok ji invited me. So good evening, everyone. I am Dinesh Kumar Pal, Health and Safety Officer, as introduced by the Ashok ji. Ashok ji, can you remove the share screen? So sure. I'm by profession and a Toastmaster by passion. If you heard anyone of the name of the Toastmasters, you will be knowing what is the Toastmasters. Who didn't heard, might be they can relate to the any bakery or the like toasting, the something. It is a pleasure to be with such a bright group of the young minds, and I think youngest mind is the Jitu sir. Just I'm kidding with you. I see here the future leaders like the students. Totally, I am totally focusing on that, and I see in them some will be the future engineers, doctors, entrepreneurs, teachers, managers, leaders, and even the innovators. So today I would like to talk about a skill that is more powerful than your score marks, degrees, or even the technical knowledge. That skill is anyone?
Communication.
Communication. So now all students, who are the students, just they can give some indication or the emoji. So I realize that how many students are here, but I will continue. If any one of you for the share your idea, even though others, not only the student, never have you ever. Is there something that you never tried or imagined but wish to experience or have it? You can send me in the chat message, and let me give an example that never have I ever imagined when I joined the Toastmasters in 2018 that I will reach the pinnacle of the district leadership role in a District 20 as an admin manager. That consists of the 5 countries, Kuwait, Bahrain, Egypt, Iraq, Russia, and Kazakhstan also now added. So that is only due to the which I am going to talk about the communication. Many students believe that success depends only on getting the high grades, or the good grades are the important, but they are only one part of your equation. Imagine this. 2 students graduate with the same degree and almost the same marks. One student can confidently explain the idea, participate in discussion, work in a team, and present projects effectively. And the other student is equally knowledgeable but struggle to express his thought. What do you think will get the noticed first? Most likely the first student. Knowledge gives you confidence, and communication gives you your knowledge a voice. Communication is much more than speaking English fluently. Communication means expressing your clarity, listening carefully, and understanding others, asking the right question, and building meaningful relationship. In today's world, every profession requires a communication. An engineer explains a design, a doctor comforts a patient, and a lawyer presents argument. A teacher inspires the students, an entrepreneur convinces the investors, and even a software developer has to communicate with clients and the teammates. No profession can succeed without a good communication. Let me ask a simple question. Have you ever had a brilliant answer in your mind, but didn't raise your hand because you were afraid or fear of the stage? Have you ever avoided giving a presentation because of stage fear? If yes, don't worry. Almost everyone experienced this in a time. The difference is that successful people don't wait to fear to disappear. They learn, practice, and improve. Remember, confidence is not something we are born with. It is something we build. And communication helps you in your personal life. It helps you make friends, resolve the conflicts, and build the trust, lead the teams, and create opportunities. Sometimes one conversation can change your entire career. One interview, one presentation, and one networking event or one speech. That is the power of communication. Now, the question is, how can you improve? How are 5 simple tips I will show you? First, read every day books, newspapers, articles, and reading the improves your vocabulary and ideas. Second thing, listen carefully. This is also one of the tip of the good communication. You have to listen carefully. Good communicators are first good listener. And third, speak whenever you get an opportunity. Don't hesitate, even in the classroom or during seminar, in a group discussion. The more you speak, the better you become. Fourth, don't fear making the mistakes. Every expert was once a beginner. Mistakes are a proof that you are learning. Mistakes are proof that you are learning. And finally, join any organization like Toastmasters, debate clubs, or any platform where you can practice speaking and leadership in a supportive environment. My own journey is an example. When I started my professional career many years ago, might be you not believe, in 1982, and 44 years before. I never imagined that one day I would stand before the audience and deliver a speech. Like many people, I was hesitant, but through continuous learning, practice, and joining, especially me, the Toastmasters, my confidence grew. And today, communication has opened. Today, the communication has opened the doors that technical knowledge alone could not. If I can improve every one of you also can improve too. Before I conclude, let me have you with one thought that your degree may help you get an interview. Your communication skill will help you to succeed that interview. And your knowledge may earn you a job, but your communication and leadership skills help you build a career. So invest in your communication skill today, because your voice has the power to inspire, influence, and create a better future. Thank you, and I wish each one of you great success in your academic journey for the students, and beyond that, thank you very much. Over to you, Ashokji.
Thank you so much, Dinesh ji. By the way, Dinesh is coming back to India soon, and the mentoring he is going to continue there also. So he is from Bihar, I understand, but now in the virtual world, everything is possible. So keep engaging with Mr. Dinesh ji, and he is very, very committed professional for health and safety, as well as for the leadership and communication development. So thank you, Dinesh ji, and we made a right choice of inviting you today to inspire our students of AP Chef. Thank you so much. And yes, as I was telling, that this is all the foundation contributions, everything is knowledge contribution, some sort of a financial contribution. We would like to thank everybody who have been doing that. These are our OKT speakers. This is the 51st OKT, and there are so many wonderful speakers we have invited, mainly from India, outside the world, and you name it. We have a global speaker fraternity, and Dr. Hari also will be part of this wonderful panel there. These are our knowledge, WhatsApp knowledge group. Just want to inform you that every Guru Purnima day, we update this. So imagine it's coming up soon. So there are a lot of new people will be joining into this panel. So these are the WhatsApp. These are our governance body and knowledge. Functional committee chairs. We have a 2 years term. 24-26 term is expiring, and we announced for the new volunteers who wants to give it back. So soon we will be establishing, as well as communicating with the old functional committee chairs, maybe having their personal issues, they want to continue or no, but we want to bring the new blood into our functional committees. And for our announcement, it is there in our website also. For announcement, we have received a wonderful expression of interest from Mr. Jeev Nath, myself and Mr. Jeetu had a wonderful almost 30 to 45 minutes discussion with him. Before I talk anything about that, I request Mr. Jeetu to talk to him about him, Mr. Jeev. We call him as a Jeev. Go ahead, Jeev. Go ahead, Jeetu.
Oh, I can go on and on and on, but all I would say is that Mr. Jeev has 30 years of profound experience in industries through oil and gas major operations in the world, and he has provided his services with a top-notch expert in health, safety, environment, and like what we just heard, Dr. Hari, this gentleman, he's also beyond and above for teaching to the industries after his retirement with the oil company Shell. He is now an adjunct professor at IIT Madras, and his ambition is to do same thing to develop youngsters and young and junior executives of industries in India and abroad to do things right, and that do things right with proper understanding. And that is where Jivan Nath, our oath, will be an asset to the foundation, and he's going to join us to support the foundation's mission with the vision that we have in excelling the profession as well as our young professionals. So we warmly welcome Jivji Jivji to share your knowledge and experience of high level and deep integrity that you have shared with oil companies worldwide. And if I remember correctly, 35 nations he has provided his services of that top-notch quality. So warm welcome to the foundation. And I think we will really benefit out of your personal commitment to the foundation's mission. Thank you so much. We welcome you.
When we had a discussion with Mr. Jeev, he was only telling one thing. Mr. Jeetu and Ashok, I do not want anything else. I got so much. I just want to give it back. And we told him, you are on the right platform, sir. So that's he has got so much of knowledge. He's going to do a lot of awareness or training or OKT sessions. And in every state in India, we have advocates in Tamil Nadu as well as West Bengal and Telangana and Andhra Pradesh. Mr. Jeev is from Kerala, but he stays in Karnataka, Bangalore. So we told him, please do advocacy to our foundation. Advocate means nothing, wherever you go, wherever you meet the professionals, talk about the foundation. He immediately agreed and he is part of us today. He was on the call, but I'm not sure whether, since the meeting is delayed, Mr. Jeev, if you are on the call, kindly speak a few words. Okay, next we will go to the another volunteer we have received. You see, Jeev is having a 35 plus 40 years of experience. We have another volunteer who is having less than 3 years experience. That's what we want. We want to take it from the experienced people and give it to the youngsters like Mr. Puneet. Puneet is for a mechanical engineer. He's working as a safety officer in Warrant High Tech in Visakhapatnam. And he came forward and he will be supporting our newsletter team. Newsletter team is such a wonderful team, but wonderful group where you have to write the articles. We have to, you will learn the learning skills as well as the digital skills. So, Mr. Puneet, are you on the call? Okay.
Hello.
So, yeah, go ahead, Puneet. Yes. So, just introduce yourself and yeah.
I would like to sincerely thank the J&A Bharat and HSE Foundation for giving me the opportunity to serve as an editorial board member, sir. My special thanks to Mr. Ashok Galapati, sir, for trusting and supporting.
Very good. Excellent. Excellent, Puneet. And you will learn a lot from the people who are there, experienced Chief Editor, Mr. Nalan, Madhu Chakravarti, Mr. Ramana, and Dr. Lakshmi Narayan. So all the best and welcome aboard. Thank you. Okay, now upcoming programs. As I said, every month we have a OKT. Another Mr. Avinash, he came forward and he wanted to do a subsidized program. So he'll be doing an online training on the process hazard analysis for a very, very subsidized amount. If anybody is interested, they can join using the link which I am showing there. You can take a screenshot. If you are interested, if you are unable to click the link, please go to our WhatsApp channel and ask for the information. You will be getting that. And our 52nd OKT session will be on 26th August, Wednesday, 20-30 hours. The cost of neglecting safety. Our Dr. Hari talked about punch patakas and reactions, and we had so many incidents in our chemical and pharma industry in India. Dr. Srinivas is going to talk about the cost of neglecting safety, why safety is the most profitable investment for every industry. So he's going to have a good case studies and information. Again, we would like to thank Mr. Jayanti Lachaya for introducing this particular speaker. We are going to look forward for his session on 26th August. Almost, again, remember participants, only on Wednesdays we have our sessions, 8:30 p.m., mostly on the last Wednesday of the month. So you can plan your activities. So again, Mr. Dinesh was telling about the communication. We are having a plan to launch Toastmasters Virtual Club. That means everything online. So now the AP Chef is existence now from today. If anybody is interested, they can reach out to Jayanti Lachaya as well as Mr. Dinesh. If you are interested to improve your communication as well as leadership skills, so we can have a virtual club under the AP Chef. And this is another support we are giving to the fraternity. This National Safety Council is doing an exam. I'm not sure it is already completed. It's supposed to be in July. But if you are interested, you can always scan this QR code and join there. And these are some of the activities we have done. And this is our WhatsApp Knowledge Hub, which I am already shared on that club. This is our foundation's account details in India as well as in US. If anybody is interested to contribute wherever you are, and every contribution really matters. And this is our QR code for the activity book. And now we have come to the end of the session with the good vote of thanks from our good friend, Mr. SPB, again, who is from Vizag. Vizag is dominating today. Go ahead, SPB, sir.
Yeah. Good evening, Jitu ji and Ashok ji and everyone. On behalf of JNA Bharat HSE Foundation, I, SPB Rangacharilu, Fire Chief, Chair for Fire Safety Awareness, presenting vote of thanks. So we thank Ashok ji for your opening remarks and launching of 4 HSE ebooks, process safety in the steel industry, 5D framework, process safety management in an integrated steel plant, smart transformer monitoring and solutions, and also launching of Global HSE Foundation and e-newsletter. We also thank Mr. Makbul for his learning management system, and also telling us about giving background of JNA Bharat objectives, vision, and the mission. So in welcome address, our Jitu ji, father of safety, he appreciated Ashok ji for his recognition by Board of Certified Safety Professionals and American Safety and ASSP. And coming to the, we thank Jayanti ji for introducing the speaker, Dr. Hari Bhukia ji, and our speaker, Dr. Hari Bhukia ji, is a loving personality, a well-matured personality, He is so respectful with elders and his teammates. I just personally met him at Delhi. Just only once I met him. So I realized all this. And his presentation, well orchestrated, excellent flow. Like our flow is like a Vande Bharat train, and no fumbling at all, and simply superb. Uh, and this session, there is about understanding reactive hazards of chemicals, process safety management. So some of these main topics were today's basic challenge for any industry, global process safety incidents, and number of incidents in India is very high. That is what he pointed out. Factories Act amendment in Maharashtra and comparative approach of PSM in worldwide organizations. So in this comparative analysis of PSM systems he talked about, and the comprehensive comparison risk assessment methodology and basic standard approach. In that he spoke about 14 elements. In some of them are process safety information, employee participation, PSSR, training, mechanical integrity. So in process safety challenges, he spoke about Chota Bai, Bada Bai, like examples in process safety challenges, and typical unit process and unit operations. So he spoke about Chota Bai, Bada Bai examples. He told us human error is a top challenge. And also process safety package, he listed about 18 packages, and how to know my process is safe or not. So he's talked about Panch Pataka, which process, which type of reaction, how much adiabatic temperature range, what is the decomposition temperature, what is the safety criticality class. So, and also understanding powder safety, understanding, and dust explosion severity. We thank Dinesh Kumarji for his moderation. We thank Ashok ji for launching J&A Bharat AP shelf. We congratulate Lachaya ji. Actually, Lachaya ji and me, we almost work hand in gloves. So
Very
we
nice.
almost daily he calls me around around 8 o'clock, and we discuss about various things, and we work in hand in hand. And we congratulate, we thank all the contributors. We thank Dinesh Kumarji for his Toastmaster program on communication skills. We thank Oduru Puneet for his contribution for GE newsletter. I thank all the members and participants for taking out time and coming. Last but not the least, we thank Ashok Garlapadaji and the father of safety, Jitu for giving us a great platform and bringing all safety professionals on board. Thank you. Thank you so much.
Thank you so much, sir. You told vote of thanks to everybody in such a wonderful way. You cover the vote of thanks. I would like to thank you for delivering the vote of thanks in a very, very nice manner. Appreciate your continued support, sir. Thank you so much. Thank you.
Thank you.
Appreciate.
Thank you.
With that, we would like to conclude our session today. And as Mr. Jitu always says, we should take a picture of the people who are staying back until the end. So I'm going to stop the recording. Kindly, open your cameras, then we will capture the picture. So these are our information. Let's continue our efforts for safer and healthier workplaces by enhancing our competency levels, which we have done today. Thank you very much. And let me just stop sharing and stop recording.